Alrighty, so we're going to talk about solving right triangles today. This should be 100% a review from geometry. Couple of little calculator notes on this before we get started is that if you are using, let's see what I have up first. Okay, so if you're using the Delta Math calculator, then you want to make sure that you are, well, on all these, right now, we want to make sure that we're in degrees. So when you bring up the Delta Math calculator, if you hit functions, then right here you have a choice between radian and degree. Make sure degree is green, okay? And then if you are using, oh my gosh, this Zoom thing's in my way every time. Okay, so then if we are using the, what is this, the Desmos calculator, then right here is where you change between degree and radians, and whichever one you see is the one it's in. It's not like I hit degree, so now I'm in degree. It's whichever word you see, so this is in degrees. If you are using an 84 of some sort, then it's under mode. And when it's cleared, the default is usually radians on any calculator. I was kind of surprised that Delta Math and Desmos, I think the default is degree because I don't remember changing it from before. But to get to this mode on the 84s or 83s or any of those sorts, you hit mode, go down, make sure degree is highlighted, and then you get out of that. If you're using something else, anything else, you're going to have to figure out how to make sure that you're in degree mode. I mean, I don't know. Because everything is different. If you can't figure it out, let me know. I can help you figure it out. Okay. Then before we even start with this, we're going to talk a little bit about assuming things. Okay. If I were to draw this, oh goodness gracious. Let's see, I'm trying to make a point and I can't even draw a decent. Okay. And I were to ask you, what is that? What's the best name you can give that? Quadrilateral. Yes, that is the best you can give it. Now, if you were in 6th grade, they would expect you to say square. Okay, and that drives me nuts, right? So I realize that you are trained to assume things, and then you get to high school and we're like, don't assume anything, right? So you can't say that this is a square. It probably doesn't even really look like a square since I drew it, but even if it looked exactly like it, we can't assume that. Could it possibly be? Yes, but all you know here is that it has 4 sides. So if I do this, right, and then I say, is the best name I can give this a square? The answer is no. What's the best name I can give it? A rectangle. Very good. And so we're going to pretend like this actually looks like a perfect square, because especially from the side. So even if it looks exactly like a square, which it might not, but we can pretend. If I do this, I still can't say it's a square, right? What's the best name I can give it? We're always slow on the drawing this. It starts with an R. Rhombus, okay? And this isn't usually how you see your rectangles in your rhombi drawn, but that's it. So my point is this. If you say, oh, that's a square, and I say, how do you know it's a square? And you say, because all 4 sides are congruent. Well, how do you know that? Well, because it looks that way. Don't ever, ever, ever go by the way it looks unless it specifically says it's drawn to scale, okay? Or there's a couple of little, like circles, if it's a circle, I mean, it's going to look like a circle. You can't help it. And there's some other little things in there and some certain whatever. But for the most part, you cannot go by assuming. So if I did this and I said, this is 10 and this is 7. And I said, which is the longest side? Well, you have no idea with that amount of information, right? So don't do anything by assuming. All right. Okay. So with all that said, let's go to solving the right triangles, which again should be 100% review. So we're solving these, and we can't use Pythagorean theorem. They're not special right triangles, so we are using trig. So what is my acronym that helps me with the trig ratios? SOHCAHTOA. Very good. So you could write that on your paper if you need to. Maybe you don't feel like you need to because you just know what it is, but I feel like at least some people are going to need to write that down. So I'm looking for x. I'm looking for a side length here. So this is my angle. I'm going to label my triangle. The side across from that is the opposite. The one across from the right angle is the hypotenuse. So I'm using opposite and hypotenuse. Which trig function uses opposite and hypotenuse? Sine. And you always take the sine, cosine, or tangent of an angle. So this is going to be the sine of 32 equals the opposite, which is 11, over the hypotenuse, which is x. trying to solve for x, not going to divide by 11 because that doesn't make any sense. I'm going to multiply both sides by x, so I get x times the sine of 32 equals 11. Then I divide by x. No, I don't divide by x. I misspoke. I divide by the sine of 32, and I get x equals 11 divided by the sine of 32. Okay, so now I've got x isolated. Now's when I get to touch the buttons on the calculator. So when I type that in whatever calculator I'm using, 11 divided by the sine, was it sine of 32? So this is what I get. If you don't get that, so make sure you're actually getting these numbers. That'll tell you if you're typing it in right and if you're actually in degree mode. So if you're using, like if you come across a little scientific calculator that happens to be shoved in the back of the drawer, or you're trying to use one on your phone or whatever, and you need to know if you don't even know if you're in degree mode or not, you can always type in an answer that we have from our notes and make sure you get the same number. All right, so that we get x equals, you get 20.758. Now here's one thing I want you to notice in the solving process. So when we have x in the denominator, I had to multiply both sides by x, and then I had to divide by the sine. So anytime I set these up, if x is in the denominator, I'm going to have to go through those same steps every time. You can skip this step. If you set up a trig problem like this, and the x is in the denominator, all that really happens is that these two switch places. It's not magic. There's a math reason behind it, but because you know it's going to happen every time, you can just jump to here, and that's fine. Okay. So 20.758, does that seem like a reasonable answer? Yes. Why? Oh, that's beautiful. So what I expected to hear was not that, and I like that's even better, is that, well, first of all, it is the hypotenuse, so it should be the longest side, and I know that because it's across from 90, but then, even better to know, is that this is pretty close to a 30, 60, 90 triangle. This is pretty close to a 30-degree angle, which means if this is 11, this should be pretty close to 2 times 11, and it is. Okay, so that's an even deeper way to just know besides just, oh, it's the longest side. So little things like that, because, unfortunately, you're kind of, and it's true for all of us that, I know that you don't have any clue in your mind what the sine of 32 right now, like you wouldn't even be able to estimate that at this point, and that's fine. So as far as this being reasonable from this, you don't freaking know that yet, right? So you just assume that whatever you got on the calculator was right. If you accidentally hit a wrong button, or it was in the wrong mode, or you did the whole thing wrong, or whatever, you could catch yourself if you just take that extra second to go, does my answer even make sense? Because one of my, when I taught geometry, there was this worksheet. Anytime I taught similarity, I always made sure I put this one problem on there, because the answers I would get were hilarious. It talked about the Titanic, and it was a ratio problem, and so it was like, so if you know all this stuff, then how tall was the Titanic? And the most common wrong answer, which happened a lot, was 9 feet. And I'd be like, okay, guys, look, I realize you may have never seen the Titanic, but you know it's a ship. Think about how tall you are. You really think the Titanic was only 9 feet tall? Come on. So you at least know you were wrong. Maybe you just don't know how to do it, but you catch those things, right? All right, so let's look at number 2. So here's my angle. Across from x is the opposite side. I'm not using the hypotenuse, so this is adjacent. So which trig function am I using? Tangent. Okay, so this is going to be the tangent of 75 equals the opposite, which is x, over the adjacent, which is 21. So what do I do next? How do I get x by itself? Good, multiply by 21. So I get 21 times the tangent of 75, and then I just get to put that in the calculator just like that. Okay, and then it tells me to round to the nearest thousandth, so you should get 78.373. Okay. So then let's think about whether or not this is a reasonable answer. This side's only 21, this side's 78. Does it make sense, first of all, that it's bigger, and second of all, that it's that much bigger? What do you think about that? And this is why we talked about the squares and stuff at the beginning, because last period when I asked that, and they were like, yeah, and I said, why? And he said, well, because that side's longer. Well, how do you know? Well, okay, so why does it make sense that it's bigger? Not because it looks that way, right? Huh? Exactly, the angle's bigger. Remember, that's how we know that the hypotenuse is the longest side, because in a right triangle, the 90 degree has to be the biggest angle, or you have too many degrees. So this has to be the longest side. So for the other ones, the longer side is across from the bigger angle. That's how you know short leg and long leg in 30-60, right? If this is 75, this has to be 15. So yes, you would expect this side to be bigger, and 75 is quite a bit bigger than 15, so even it being a lot bigger kind of does make sense, okay? And you don't have to spend that much time analyzing your answers every time. If you get used to doing that, it'll just take a second or two to go, yep, I think that looks good. Doesn't always guarantee you're right, but sometimes it helps you catch things when you're really wrong. All right, any questions? All right, y'all do number 3 on your own. What do we get for x? Did I give you enough time? 27 point what? 615. Very good. All right. Any questions about that? All right, then you do 4. So did you get, what, 17 point what? Did it go too fast? Okay, yeah, 256. All right, so let's talk about this answer. So one way you could know, so not only above like bigger angles or whatever, but if these two angles were both 45, this would be an isosceles triangle, right? So these would both be 15. So it's clearly not isosceles, but the closer these angles get to both being 45, the closer these two numbers get to being the same, right? And so this one's just a little bit smaller than this angle would be, and so that's a little bit bigger than 15. It all makes sense. We're all good? All right, so let's talk about finding angle measures. So it says, given the trigonometric, oh my goodness. Okay, given the trigonometric value of an angle, use the corresponding inverse trigonometric function to find the measure of an angle. So if I have the sine of theta equals x, you always take sine, cosine, or theta of an angle. So if I know what x is, like I have the ratio, but I don't know the angle, and I need to get theta by itself, I need to get sine away from it. I don't get to divide by sine because this isn't multiplication, right? I have to do the opposite. If I divide, it's because I multiplied. If I add, it's because I subtracted, right? If I took the square root, it's because it was squared. So if this is sine, then I have to take the sine inverse. So that means that, that means if I want to get theta by itself, theta would equal the sine inverse, or the inverse sine of x. So you take the sine, cosine, or tangent of an angle measure, you take the sine, cosine, or tangent inverse of a ratio of sides, Okay. Another way to say this, so it says note, sine, it's not to the -1 power. That's what it looks like. That's how you write it, but that's not what it means. It's read as inverse sine of x or sine inverse, or it also could be arc sine of x. That means the same thing. Arc sine you use kind of in the higher maths. I don't know if it just makes you sound smarter or what, but they're interchangeable. It's the same thing. So if I have the cosine of theta equals x, then theta has to equal the inverse cosine of x, or the arc cosine. I feel like I probably spelled that wrong last period. All right, and then theta here for tangent would have to equal the tangent inverse of x, and then theta would also equal the arc tangent. I cannot write. I was trying to undo that. Arc tangent. There we go. Of x. So I want to show you why it's definitely not to the -1 power. Okay, if I have 2 to the -1 power, what is that? 1/2. Okay, so if I take sine of theta to the -1 power, that's going to give me 1 over the sine of theta, right? So it's the same type of thing. And then what is 1 over sine of theta? What's the reciprocal of sine? We talked about it yesterday. Cosecant. Very good. It is the cosecant of theta. So taking sine to the -1 power actually gives you cosecant. It doesn't give you the cosine inverse. I still wouldn't get an angle. So it's not to the -1 power. All right. Any questions at all? All right, so let's do one of those. So I want to find the measure of theta. We set up the triangle the exact same way we've been doing. This is my angle. So across from the right angle, this is my hypotenuse. This is adjacent. So for adjacent and hypotenuse, I'm using cosine. So the cosine of theta, because it's always of an angle, is equal to the adjacent over the hypotenuse. I need to get theta. So theta is equal to the inverse cosine of 18 over 23. So then whatever calculator you're using, you're going to have to figure out how to get the inverse, which sometimes it's shift, sometimes you have to hit extra functions. It just kind of depends. If you're using an 84 type calculator, it's shift. So I'm going to do, or second, I'm sorry. Second, I already forgot I was doing cosine of 18 divided by 23. And if you can't find it or figure it out, if you have sine, cosine, and tangent there, the inverses are there. I can help you figure it out. They can all just be so different. So this is the number I get, and it says to round to the nearest 1,000th of a degree. So this would be theta equals 38.500 degrees. Okay. Any questions at all? All right. Then y'all do the next one, number 6. So did we get 13 point what? 774. And that's degrees, right? Because we can actually put the units on there. There weren't units on the side links, but. All right. Everybody good with this? Little refresher here. Alrighty. So then let's look at solving the right triangles. All this really means when it says to solve a triangle means you find everything you don't already know. So the easiest thing on number 7 probably to find would be angle B. So how can I figure out what angle B is? Okay, so I can add these two together and I can subtract from 180. Totally fine. Absolutely nothing wrong with that. Somebody tell me something maybe even a little shorter than that. Do I have to add these two together and subtract from 180? Like, what do these two angles have to add to give me? 90. So I really can just do 90 minus 72. But it's fine either way. It doesn't matter. Even though 90 minus 72 should be super easy, should you be able to do that without a calculator? Yes. But if you're using a calculator, use the calculator so you don't make some stupid mistake on an easy subtraction problem, right? I mean, if it's there, use it. So we should get 18 degrees, right? Anytime you solve anything, if you can use what they gave you to find what you need, use that instead of what you found. So basically, I could use the 18 degrees to help me find the side lengths, but what if I did subtract wrong? Or what if I wrote it down wrong? Or what, anything. Anything could happen. We make ridiculous mistakes. So the safest thing is always to use what they gave you if you can. Sometimes you have to use what you found, but whatever. So this is my angle here. We already found B. I'm not even going to label it on here. And I need to find, so this side is going to be my opposite. This is the hypotenuse. This is the adjacent. So we'll find BC first because that's what's first up there. So to find BC, I'm going to use the angle they gave me and this side that they gave me, and I have the opposite. So opposite and adjacent means it's which one? Tangent. So I'm going to have the tangent of 72 equals the opposite, which is the length of BC, over the adjacent, which is 15. So that means that the length of BC is 15 times the tangent of 72. Okay, so I get 46.165. Everybody good with that? All right, so I could use this number and 72 to find the hypotenuse, but why in the world would I want to make my life more difficult when I can just use the number that they gave me? So adjacent and hypotenuse is cosine. So the cosine of 72 is 15 over the length of AB. And then these two can just switch places. That's 15 divided by the cosine of 72. .541. So if I look at these, okay, yes, my hypotenuse is the longest side, so that's good. But this side length is pretty close to being the same as this, so this triangle is definitely not drawn to scale. But the smaller and smaller this angle gets, you can think of it as like a ramp that's going down, then the closer these two side lengths are to becoming the same measure. Okay. Any questions at all? All right, so let's look at number 8. On number 8, I have to find both acute angles and a side length. So I could start off finding, you want to find the side? So we can find JL first, right? So what am I going to do to find the side length? Pythagorean theorem. So I've got 7.6 squared plus JL squared equals 8 squared. So I'm not even going to worry about actually squaring them. I'm just going to make this JL squared equals 8 squared minus 7.6 squared. That means that JL is the square root of 8 squared minus 7.6 squared, and the calculator will do all the stuff for me. All right, and so we should get for JL, what did we get? 2.498? What you got? Okay. So I could use that side link to help me find the angles, but again, why in the world would I do that? So let's see, we'll find angle K. So we'll go with angle K. This is the opposite, this is the hypotenuse, this is the adjacent. So I'm going to use adjacent and hypotenuse. So the cosine of angle K is equal to 7.6 over 8. So that means that the measure of angle K has to be the cosine inverse of 7.6 over 8. So when I type that in, it's my cosine inverse of 7.6 divided by 8. Okay, so that gives me one of my acute angles. I could totally use trig and the information that they gave me to find the other acute angle, right? Or I could do what with that number? Subtract it from 90. But you never want to use your rounded numbers, okay? You have to use exact numbers. Now, one of the downsides of the Desmos and Delta Math calculators is I don't think on either one of those you can store numbers. And so you can on these and you can on some other things. And we're going to need to do that at some point. We don't actually need to do it here. So I could do 90 minus the answer. I think some of them have an answer button. Like on this one, I could do 90 minus, so I could do 90 minus, and then I could do second answer, and it uses the answer above it. Or if you're lazy, like I am, what I usually do in this case, because I don't want, that's a lot of button pushing, I just do 90. Oh, no, I don't. That's not what I want to do. I just wanted to do minus 90. So basically, I'm taking that number and I'm subtracting 90 from it, which is backwards. But when I'm doing it, I know it's backwards. I'm just lazy about typing the stuff in. So when I get that and I get that negative 71, I know it's really just a positive 71. So if you learn how to manipulate the numbers on the calculator, I'm just saying it can, save you some steps or whatever, especially depending on what kind of calculator you're using. So I get for angle K, we got 18.195. degrees. But again, to find angle L, I could have used opposite and hypotenuse. I could do the sine inverse. You'll get the same answer either way, and that is 71.805 degrees. Okay. Any questions at all? We're good? There's your review of basic right triangle trig. Then we'll get to the fun stuff after Thanksgiving.